Yeah, hello everybody. Welcome to our second kickoff session here for the CPF and the TAQ programs. In the first session, we have covered the basics on a pretty high level. I would say like the 30,000 feet view from the top to the elements of the program, to the guiding principles, to some motivational factors where we argued that in order to become a super quant, you need to master the domain, you need to master coding itself and understand what this code is about, like also software development, machine learning elements, but also the most recent AI technologies that you need to be able to leverage in a way that you can apply it in practice. Because the problem is, and this is what we have discussed, that if a novice coder or a junior quant who doesn't have that much experience simply relies on the AI, this might lead to serious issues in the end. And when you think in terms of production in a buy side or sell side institution, for example, a hedge fund or an investment bank, and you don't really know what you get from the AI, and you put it into production, and production means that money is shuffled around by that code, right? This is then a serious topic, not as serious as maybe in the emergency room of a hospital, right? We are still in the financial domain, that's true, but nevertheless, we can imagine that such issues are to be avoided. So, super quant, meaning coding, domain expertise, plus AI leverage. This is what we strive for with the programs, so equip with all the necessary skills from these three domains or subdomains, I can say, right? So today's session is absolutely on the practical side. What I have been thinking of is to do with you a rather brief and concise safari through certain topics that you will encounter in the CPF, the TAQ program, right? So that we have at least a little bit of a code twist to our introductory kickoff sessions here as well. Don't confuse this with our proper teaching sessions, right? This is just if you like to whet your appetite, to touch upon and to discuss certain topics that you can expect, but you don't need to follow along every single minute detail, and the expectation is not that you get everything, every detail on the first go. Be assured, everything that you will see today will be covered in every detail later on in the single modules of the different classes. So you have seen the overview of the classes. When I jump here to this overview charts, there's so many topics here, but I thought it would be good to maybe get a pretty concise digest of what we can expect here. And I would start with the tools and skills part, also related here to Linux, how to set up an infrastructure, a Python environment, how to set up a Jupyter Lab in a Docker container, and then run a Jupyter notebook, which will address a couple of important topics that will be part of the program in the upcoming weeks, from, let's say, asset management and or algorithmic trading, right? So that's the basic idea for today's session, being a bit more practical, providing you a code-based overview in the form of an appetizer. And let me get started in this context by changing to the command line. Before I change to the command line, I get started with our today's topic. Just a brief look here on the Quant platform. So you see on the Quant platform the session number 1 here that is already available in recorded form. There's already the summary automatically and AI generated, and just for fun, I have implemented a search for our topic super quant, and you see here 172 hits, but this is related to super as well as to quant. But here in particular in the video from the first session, you see a number of these hits. And for example, there you see Super Quant mentioned. And when I click on this and mute my own voice here, you see that you can jump from the search result immediately to the very second in the video where this expression is mentioned. So it's all there. Usually it takes a little bit, let's say not more than 1 hour, generally speaking, until the live sessions are available on the Quant platform in recorded form. And including generally the resources that come along with it. So here in that context, it was just a video and the slide deck. Usually there will be Jupyter notebooks and maybe other files that accompany such a module. This just as a reminder that everything is already available and will be available shortly after the sessions take place in the future. So let me close that one. And here you see already something that I have prepared for a little bit later. Right, I said I'm going to change now to the shell here, and on the shell, I'm now going to create a Docker container. If you have never heard of Docker containers, think really of it like a physical container that you know from the shipping industry, right? Like a metal container. And here, this is something similar, but of course, in a technical sense. And we will create a containerized version, as to say, of a Ubuntu, of a Linux operating system on my base host Mac operating system. This allows me to work with Linux, and for the sake of my illustration, also to get started from scratch, because you can imagine on my machine there are basically a couple of Python environments that I use for different purposes. So here I want to get started from scratch and show you that even if you haven't worked with Docker containers before, it's not magic. A couple of tricks will do for you, or at least for what we are doing here in the program. Of course, there are specialists, sys administrators, etc. out there. They have completely different use cases for containerization, etc. But this is not our topic. So let me get started by Docker run -gi for an interactive session. Right. The first thing that I'm going to do is I name this here, and let me call it Safari, which is also part of the name of the Jupyter notebook, right? I want to mount a volume, and this is my current working folder, and I want to mount it to root and here also live, because here my local one is called live as well. And I need a port. So one here that I usually choose is 9999. And the image is Ubuntu latest. That's the standard, the go-to image. And these are all minimal base images, right? They don't come with that many batteries included, but more on this in, for example, the Linux basics class, in the data science basics class, in the tools and skills class. So there are many classes, modules, and opportunities for you to go through all these topics in detail. And I want to run the bash shell here. So after a little while, you see the prompt changes. Here I was logged in, or I am still logged in on my host system as Eve, but on the terminal, it has now changed to root at Safari, and this is now our Linux environment. Let me navigate to the root folder here, and you see there is the live folder. When I have a look at the live folder, this is what is stored locally on my machine, and this is basically the only folder that I have access to now. I don't have, given my setup here, access to other folders on my machine. This has advantages, in some cases disadvantages, but this is explicitly the way I wanted to have it here. So first, a little bit of housekeeping update. So first step, this is to update the installation. First, the package index. That's, as you can see, a pretty efficient affair. And the next thing is upgrade to upgrade all the packages, and you see here 37 packages can be upgraded. And this is similar to everything that is happening on a Mac machine or on a Windows machine, where every once in a while there's a need to update packages. Here we are on the technical side, nothing visual, so just a server-based system, which is much smaller, leaner than desktop versions, which I run, for example, on one of my older MacBooks. So I use it there as well every once in a while, but not really for work because it's a relatively old MacBook, but it's a good use case for my MacBook, which is a 2013 MacBook Air, just 4 gigs of RAM, i3 processor, and Ubuntu with a desktop capabilities runs there like a charm, I must say. So we have done our housekeeping, and the next thing that I want to do is I want to install Python, because when I do a quick check, Python is not there, IPython is not there, Jupyter Lab is not there. So we are basically here on a blank system, no Python whatsoever in the program. Usually what we use is Miniconda. For example, the data science basics class goes with built-in capabilities of Ubuntu with pipx, as it's called there. But here I go with what I've prepared here, namely I need an installer and I want to have Linux, Miniconda for Linux, but I'm on ARch 64. This is the appropriate one for my Mac Apple Silicon machine. If I would use a Intel-based Mac version, for example, here the direct one, or Intel here for Linux. So you see there's a long list. The latest ones are up there, so I go with that particular one and copy the link address. So that's basically it. But what I need is a tool now to make use of it. Up install wget. Wget is a simple tool, but a useful tool. The Linux world is driven by dedicated, highly specialized applications and tools that do usually one trick, but they are pretty good, if not perfect, at doing that particular trick. So here it's a simple trick. I just want to retrieve here the installer from the server. Depending on your internet connection, this takes a little bit longer or goes a little bit faster. And I have now here the installer. I install this via bash miniconda 3, etc. Pretty long name. And here I now go through everything. Yes, I accept the licensing terms. I agree here to the path where it wants to install it. There have been some warnings, but I don't think that this leads to an issue. Here I now say yes to the change of the bash one, right? So it has changed here. You see modified bash RC. For those of you who are used to working with Linux and the bash shell, you know what's going on there. But I still do not have Python available. What I need to do is I need to restart bash again, and suddenly here we have base appearing, and this means that we are now in a conda, miniconda environment. When I now type Python, it really starts. So it has installed 3.13. It's a later version, right? So this was just for check. I can exit it. When I want to run IPython, a tool that is regularly used throughout the programs, this is not yet installed, but with conda install IPython. Let me do one such install. Here you see it asks me whether I'm sure that I want to install it. I say yes with all the dependencies that are required, and now I'm here on the shell and can do simple stuff like welcome to the CPF and TAQ Safari. So our first Python line of code, including syntax highlighting. IPython can do many more tricks. It's really powerful. interactive environment, but this is not the primary thing that I want to use. Therefore, I leave it now. Yeah, for the time being. Of course, I could later on visit it. So now for what I want to do with you. So LS Live, let's have a look. Here you see there is a Jupyter Notebook, CPF Safari, there is a PDF, which I will share later on, and there is a YAML file, right? And the YAML file, YAML is looking as follows. So here, channels are defined, right? And dependencies, Python 3.10. This is different from what we have. NumPy, Pandas, SciPy, Matplotlib, PyTorch, transformers, Jupyter Lab, IPy So what is this? Yeah, this is a configuration file which you can use in combination with the Conda installer. Recall, I have done Conda install and then I did IPython, but I would say the most important packages for what we do are all available via a standard Conda install. So here we could go now and do everything like this step by step, first creating an environment and then installing NumPy, installing Pandas, installing SciPy, Scikit-learn, Matplotlib base, and so forth. You get the point, right? But I want to do this now differently. I want to use this YAML file here, right? And this is here in plain text, but when I let me just install Vim code editor, which I like to use, which you will be presented with a number of times as well in the program. And we are here 7, so in Germany. So warning skip creation. I don't know why we get all these warnings here, but Vim, yeah, I can start it. And when I open here live CPF YAML, so I've now opened the file, and this makes it, I would say, a bit better readable because the YAML file now gets here some syntax highlighting. Not that much, but at least a little bit. We can see here it better. So I was saying that we can use this file to create a Python environment, which after the creation includes all these files, right? So we started from scratch. We did our housekeeping here on Ubuntu, but even after the housekeeping, there was no Python whatsoever available. So then I downloaded Miniconda, installed Miniconda, which comes along with a standard Python interpreter, as we have seen, which comes along in particular with Conda, package and environment manager. And now I want to install everything for our Safari. Among others, you see here Jupyter Lab, right? Or transformers, right? This is for natural language processing, right? NLP. Or PyTorch, this is for deep learning, right? Or Matplotlib, this is for visualization. Everything that you see here, you will be able to find in other places and will be presented with. What I must say, but my plan is to do more in the future. Currently, almost all of the deep learning parts in the program are with TensorFlow Keras, but I don't know, for whatever reason, yeah, this package has become less useful, and this is really something, how shall I say, that is a bit surprising because it was so useful in the beginning, and I love the Keras part in particular, and most of the stuff that you see is done with Keras. But recently there have been issues. So starting, for example, with my reinforcement learning book, the code with later TensorFlow version was so slow that it was prohibitive, right? From execution times, let's say, of a few minutes to hours on end for a number of reasons. Therefore, for example, to make it concrete, I just recently added PyTorch versions of the code for reinforcement learning for finance to the GitHub repo so that everybody can rely on these versions as well. So just as a highlight, because here I get started already including PyTorch instead of primarily TensorFlow. So Enough about the background, but this is what I wanted to do here. It's like if you are on a safari in a Serengeti, right, you will have your guide which explains everything, and this is how I see my role. I try to explain as good and as much as possible, right, so that you have your expectations and hopefully your motivation right for the upcoming weeks. So with that file, I can close it now. This was just for inspection. I don't want to change anything. So the other file is empty anyways, so no problem. I'm going to create now an environment. When I have a look at the environment list, there is just one environment. This is the active one, base. So that's not a surprise that it's active, right? Because this is indicated here. So this indicates that the base environment Python mini conda is active. So I'm now going to create another one, conda and create from file. Now this is where the YAML file comes into play, CPF YAML. So again, I don't need to type everything like PyTorch and this and that. Now it takes the file, goes through it step by step, checks the channels, PyTorch, defaults, conda forge. These are different channels, so to say, different repositories from which it can retrieve packages, right? And it's already installing, like NumPy, Matplotlib. What else do we have? SymPy, Pandas, Python 3.10, what I requested. What else jumps to my mind? IPython, right? I installed IPython in the base environment. Here it's installed once again. Yeah, that's basically it. And you see this works, hopefully automatically. There's no guarantee whatsoever because we are dealing with technology. In technology, you hardly ever get a guarantee. But this worked here as it seems like a charm. And what I need to do now is conda, here you see it. I could copy it or I type it now. Conda activate CPF Safari. Right? The prompt changes here from base to CPF Safari, conda and list, and you see two environments. One is active, and that is the CPF Safari. No surprise here at this point. So for our Safari through the topics now, you might have noticed, recognized that so far there is no finance whatsoever. Everything that we have been doing here is valid for whatever use case you have. If you're writing your PhD in biochemistry or in physics or in any other field, this would be the same stuff. No finance whatsoever, nothing special. Even the packages, there's no, let's say, dedicated financial package that I have retrieved. And this holds true basically for, I could almost say, most of the classes. Here you see there is, for example, our financial packages class, which covers dedicated financial packages, for example, for backtesting of algorithmic trading strategies, right? But in most of the other classes, like here, PFF key skills, let's say, at least I don't recall. The same holds true for NLP. At least I don't recall that there is anything really special for finance, right? If we use PyTorch or TensorFlow or Scikit-learn or SciPy or SymPy or whatever, these are general packages, right? And this is something that I've tried in the past to do as far as possible, that we rely on the most standard packages. This is not always possible. In algo trading, we use Quant starts for the calculation of typical financial statistics, etc. Here, as I mentioned, specific packages, and of course, for the pricing of derivatives, right, we use our own library DX. But for example, I just recently updated the code of DX, and it relies more or less exclusively on NumPy and Pandas. And the upgrading was really seamless because there is no real special stuff included, right? This was always one of my personal guiding principles, to stick to the basics as far as possible, which does not mean that you should not use something that is dedicated and specific. But generally speaking, the more you can put on top of the workhorse packages like NumPy, Pandas, Matplotlib, etc., the better usually going forward and yeah, in the future. So this again as a little bit of background. So I'm now going to set a Jupyter notebook password. No need to do that, but this sometimes simplifies. So I should write the correct thing, Jupyter server password and not Jupyter notebook password. So the password is set via Jupyter server password. And I'm choosing here a simple one. This is not necessary. This is how I started before, because I'm here working in a local environment. Nobody else from the outside world can access my machine. I hope at least so, that it's not hacked. But I'm halfway sure about that one. And when I now start my Jupyter Lab server on the local, on all local IP addresses, and now take care, this is here where I go with the port 9999. You recall when I started a Docker container, I specified this one port. And last but not least, I need to go with allow root. And this command now starts Jupyter Lab. And this is the URL where I can access now my Jupyter Lab. So here, for example, let me just close this. We don't need the installer once again. We have it downloaded. And here we have now Jupyter Lab up and running. And you see there is my live folder with the files that you have seen before. So you will see me do the following quite often. At first, no, I don't want to get notified. Then I change in the settings, usually to dark. I prefer dark. Many others these days do as well. And then I have a set of, let me change here the name to text, because otherwise it doesn't open in the editor. I have my own set of shortcuts. You can imagine when you work with such a tool on a daily basis, and usually for hours on end, that yeah, you want to have it as convenient and as efficient as possible. Therefore, I have my shortcuts. These are the same on the Quant platform. I show you, or I mentioned them. So I need to go to keyboard shortcuts, and simply under user preferences, I paste now my shortcuts here. So among others, just to mention one, you see it here. What I define for myself here is shift and control. This is displayed here for Mac, right? I look at my own keyboard here. Mac keyboards, Windows keyboards are slightly different, right? But on Mac, this is Control, Shift, and N. Restart kernel and clear is Control, Shift, and 0, right? Restart kernel 0. This is standard. II is also standard. So there are already pre-configured shortcuts, but I have a few of them here, my own. Also Control Shift Y, Control Shift X, and so forth. When you go through it, you will see immediately, because it is yeah, more or less self-explaining. Here you see activate next tab. This is Control Shift L. You see I have all my shortcuts, basically all, I think, at a Control Shift and then a third key. Control Shift X means run all above. Control Shift Y means run all below. I don't know where my Y sits, right? But you don't have to do this, but for me, that's a matter of absolute convenience. When I now open here the only Jupyter notebook that we have in here, right? I can go to the View tab and to the table of contents and say here show or click on show first level. So now it is as it should be numbered. So there is no need to number it, but I think this is a nice functionality, a newer one, right, where you can number your sections as you would number, for example, a paper, right? First section, introduction, second section, case study, right, and so forth and so forth. And you see here in the overview, so let me get back here to the file browser. This is to 99.9%, I would say, what you see, right? Modified, usually I have also here turned off. And for you, the text is there to read, right? This was generated based on my input by AI. And I mentioned that we use AI these days intensively as well for stuff like this. It's perfect. But it relies, at least in part, of course, on what we do in the program, right? And again, I'm not pretending I personally have written it when it is from the AI. I think this is here, right? You see here with Gemini. But we must also see that, for example, all these models are trained on all my code, for example, in all my books that I've ever written in the past. And I can tell, given a couple of examples that I've seen for specific prompts, that indeed it was trained on my code, because there are, of course, some specifics. But enough about that. Here, the Safari will touch upon some basic Python stuff. So we have Python basics, Python key skills, for example, cover that stuff. Then we have NumPy covered there. We have Pandas covered there. Pandas, you will see, and NumPy basically in every corner of the programs. Data storage. I have chosen this topic in particular because I have added this, and this is also current topic still in the data science basics class. Scikit-learn is used in so many instances. In the NLP class, right, we use transformers extensively, right, for natural language processing. Here, the example is about sentiment analysis, then asset management, computational finance, and algorithmic trading. So I tried, in the sense of in the spirit of a Safari, to touch upon several important topics, right? So the case study initial setup. So first, we want to define some basic parameters for the analysis, right? Like assets under consideration. So the whole thing is about trading and portfolio composition with some preliminary work here. That's the story, right? We have, of course, built in data types and structures. And you see here, the first thing is that there are some assets that are defined. So 3 assets: Apple, Microsoft, Google. You will see these used also a bunch of times in different classes. Risk-free rate, and then we have the configuration starting at the beginning of 2022, going to 2024, and the data source is from wherever. So here, that's a simulation with fictional data, basically. So we can now check what we have defined. So this seems all to work. And now a simple control flow, right? We have here a list object defined. We have a floating point number. We have a dictionary. Here, that stuff is printed. And now there's also a bit of control flow, which is, of course, pretty important. Target asset, Apple. If target asset is in assets in that list, then we say it is included. Otherwise not. So for example, if I would say Apple.O, which is the Thomson Reuters RIC version of the Apple stock ticker, I would say is not included, right? So just to get started with, very simple stuff. Here you also find the explanation. Since I'm talking about it, there's no need that we read it here once again. I think finance, and I'm speaking now about like 10 years plus back, many people from finance were drawn to Python, in particular due to NumPy, numerical Python, because Python in and of itself, for many calculations, simulations, etc., is relatively slow. You might have heard this. in many instances, this is not true anymore, but for large-scale numerical operations like vector operations for linear algebra, this is still the case. But using NumPy, on the other hand, makes that stuff almost as fast as if it would be implemented in C, because under the hood, NumPy is primarily implemented in C. So here we calculate now the portfolio return as the weighted average of the individual asset returns, right? So typical, here in that case, it's simple. It's a dot product between a vector and a vector. So pretty simple, straightforward to get started. But that's the first NumPy example. I need to import it. Here's some hypothetical returns over 5 days for the 3 assets under consideration. And yeah, we can, for example, look up here an attribute of that object, 5, 3. Then the number of assets here, shape 1, is 3. The weights, if we go with equal weights, right, we get here a third, a third, and a third, right? So when we have a portfolio, we say Apple, Microsoft, Google, and we say, yeah, I want to invest like a third in the 3 of them. This is not like the capitalization-based approach. This is simply equally based, and it's not price-based or whatever else we can come up with. And the returns, the portfolio returns daily are returns, and here we have the operator for dot operations. To be honest, up until today, I'm using NP dot. I don't know why. With the at operator here for matrix multiplication, I'm still not really warm, but of course this works. The alternative, which you will see in the program throughout, is to write NP dot weight returns and weights. Here's matrix multiplication. In the end, it is probably more natural and also probably better readable, but be careful with regard to the sequence, right? So we have calculated the daily returns based on the weights, and we can now have a look here at the daily portfolio returns over the 5 assumed days, right? So total portfolio return over the 5 days, and this is here the net return, right? It's the product plus here, this is the net version of it, is 0.02. So it's like 2.2%. If we wouldn't subtract the 1, we would get the cross return here. Therefore, I'm highlighting here net once again. Again, you get here the explanation. In particular, here returns are 2-dimensional, weights are 1-dimensional. So what I mentioned here, so the sequence for these operations, same operation but different implementation, is important. So as I was saying, NumPy is what has drawn many finance people also to Python, right? And it's also the basis of what is often called the data science, or back in the days they called it usually the scientific stack. Yeah, because NumPy is at the core. Pandas uses it, Scikit-learn uses it, Scikit-learn uses Pandas. So this is all built, if you like, on top of each other. And I think this brings along a ton of synergies. Speaking of Pandas, so Pandas is something that has drawn even more finance people. I would estimate, I would guess, to the Python ecosystem, because it was from the beginning designed by Wes McKinney to manage time series data, right? So to manage historical stock price data, for example, but there is much more time series data than just end of day stock price data. But of course there is, right? So here we are dealing again with something artificial, fictional, namely with random data, right? Usually we would retrieve it either from a API or from a fixed data set. So here, for the sake of easy reproducibility, with a couple of configurations for the plotting, we generate our financial data ourselves. right? So here you see could be from CSV or from a database or from an API. So there are so many different options from where we can retrieve that. Yeah, here just again as the most simple case, namely you bring along your own data for what is coming. So, and we do, as you see here, the NP random seed, and we generate the random numbers with NumPy. So here was the NumPy part, right? We save it in a dictionary once again, and afterwards, with the date time index generated here, 400 values, 100 values here, here, right? And here we use this date range object plus the data in the form of the dictionary with the random numbers, and then we do some clipping here, right? So that's arbitrary. If you repeat this, change the seed value, you get other stuff. We can do this on the fly. So we get the data here, 150, 280, 99. These are not the real values, for sure not. We can calculate now easily the daily percentage returns, right? We can then show them, display them here. This is done via printing. There are also multiple ways of doing it. And last but not least, we can plot it. So this is now the output, normalized plot starting here at 100. So before the data was not normalized, right? Now it has been normalized. You see here, this is the normalization procedure. All is vectorized. Basically, all that you see here in that Jupyter notebook is vectorized code. And again, these are random numbers. If I change the seed here, let's say to 1000, we get different values throughout, and also here a different evolution, right? So that's simply a given and something that you will also see and experience and probably use for yourself a large number of times. So we can, for example, here check for the rolling correlation, and we see here then the results presented, rolling window, correlation, and this is for Apple with Microsoft, and we have a correlation of 0.2. So it's not zero, which could be a result for the random numbers, but it's also not, let's say, close to 1 or close to -1. Again, a couple of explanations to what has been used here. All very, very, very important functions, or here I'd rather say methods, that we call on the single objects for time series management and handling with Pandas in finance. So once again, in data science basics in that class, one of the last sessions introduced SQLite, which is most of the times a built-in package for CPython, meaning the interpreter that we have installed previously, right? So there is no need to install this separately, generally speaking, and this is the case here, at least for us. So I can import a SQLite 3. I open a database file here. I could do everything like here also in memory, but I do it on this. So when I have created this and click on it, you see here on the left-hand side, there is now financial data.db. And here's some SQL, create table if it not exists, and it's called stock prices. And I want to write now my randomly generated stock prices in a SQLite database, right? And this is the first SQL command in order to create a table where I want to write it. And we will have here a date, here as a primary key, and then Apple, Microsoft, Google. So 3 columns with that data, right? So creating it, and here the code uses to SQL, that's a method on the data frame, to write the stock prices in the SQLite database. There are, again, multiple ways of achieving the same result, but here Pandas is used, which is in particular pretty convenient, I must say. And in the next step, you see that there is data queried, which is later than 15th of May 2023. So not the whole data set is queried, but rather the stuff which is later than a certain point in time, given the date information in the database, right? As simple, as clear as that, and it's also relatively fast. And we get, this is explained in the data, again, I repeat myself here in a data science basics class, it's a pretty flexible technology, not the fastest one if you just want to dump data on disk and want to retrieve it. But if you want to implement more complex operations, for example, then this is a good way to go. So this next command simply deletes here the file once again, so that it's not persistent. A little bit of an explanation as before. Now, predictive modeling with Scikit-learn. So factor modeling and factor investing, of course, something of importance in finance. Here, a very simple example where we are not going with more sophisticated factors like momentum or volatility or whatever jumps to mind, like size, right? This is not about that. Here it is related. The factors are related to time series elements, right? So we use linear regression, typical model. You see here we have a fixed constant that we have beta 1, beta 2. If you would have just beta 1, we would call this alpha, and this would be the capital asset pricing model. If we choose x1 appropriately, right, with epsilon here be the residual, and the model shall learn coefficients better to minimize prediction error. So here what is used is Scikit-learn, a linear model, train test split. We work here with Apple, and you can imagine working with random data doesn't lend itself pretty well for any kind of prediction exercise, because by the very construction, the data is random. Here it is about the code and how you could implement such an exercise with Python using Scikit-learn plus Pandas and everything else that we have seen before, right? So we go with the returns from Apple. Then we take as the first factor the lag number 1 of Apple, and then we take the market lag, which is here calculated over the 3 assets that we have in a data set, right? And the target variable is Apple itself here, right? And last but not least, we do a bit of housekeeping, getting rid of not a number values, right? When we have a look at this, we have Apple as target. These are return values, right? We generally work with returns in these contexts. Then we have Apple lag 1, market lag 1, target here, which is given like twice here, right? Left and right, but to specify it, it's target. And we define now the features as well as the target. Apple lag 1, market lag 1 are features. Target is our labels data, right? And now we do a train test split, as is easily accomplished here with the convenience method or convenience function from the Scikit-learn package, which was imported previously. Then we do the regression, right? We do it on the training data, and the test data is used to do the prediction, and we can then compare our quality prediction here with the test set. Again, this is for the sake of illustrating the code. The data in and of itself is nothing that we would like to apply here. But if you get your hands on this Jupyter Notebook, you can go from A to Z. And with the environment installed, as I did before, you can exactly replicate what I was doing here, right? So a little bit of a factor-related model to predict future returns. They could, for example, then be used as input into an asset management model, right? Or for trading or whatever, right? So natural language processing, also a large class that we recently introduced, from the very basics, working with strings to regular expressions to really attention mechanisms, transformer models from scratch, and leveraging here via the transformers package also the different pre-trained models that are available on Hugging Face and others, right? So that's I think also an absolute strength of the Python ecosystem these days. So I have it installed via the via my environment package, right? I instantiate here the sentiment analyzer. You see here there's a little bit of output, right? So this is just for the sake of information. So this is not like an error. So here I progress not found. This might be used. I could, for example, install, where is it, IPY widgets in order to suppress this warning, or I could generally suppress warnings or these outputs, but these are not anything for concern, right? We just live with it and notice what is happening. So now some sample headlines related to Apple. Also an example that I regularly use in our NLP classes and exercises. Apple shares surge after strong earnings report. Analysts worry about Apple's supply chain. Apple unveils new iPhone with only minor upgrades. Demand for Apple Vision Pro exceeds expectations. So, of course, these are headlines that are invented, but I think they are realistic. So it's nothing where we would say this could never be the case in this universe or in this lifetime, right? So, and the idea here with the sentiment analyzer is simply to take all the headlines here and to put them through the sentiment analyzer, which we have instantiated here, right? To come up with something that for us here is, I would say, pretty clear, right? This is, oh, Apple share surge, positive. Analysts worry, negative. Apple unveils with only minor upgrades. Yeah, this is not really positive. Maybe neutral, but rather negative, right? Demand exceeds expectations. That's positive. Let me see what, or let us see together what the output is here. So we have here positive, negative, negative, positive, right? So that's a typical application here in NLP sentiment analysis. This can be done with X posts or any other news articles, whatever you get your hands on, right? There are many news feeds these days that you can access via API, and then you can, as you see here, make an automated sentiment analysis on top of that to get like a feeling for it. Just imagine Apple event. Every once in a while you might have followed along one of these events, right? And in the aftermath of such an, even before, right, people speculate what will be revealed and here and there, but in the aftermath there is a flood of articles coming out by every news outlet, by even the YouTubers, the podcasters, the whoever's in the world, and it's pretty difficult over, let's say, the next 24 hours to follow along everything. But with automated sentiment analysis, of course, you can get even in real time. And we have implemented this, for example, a while back with Dow Jones on their professional grade live news streaming APIs, right? A real-time sentiment analysis for crypto markets, right? So this is relatively easy and straightforward to implement, and Python, of course, is your friend here as well. So now to the core topics: asset management, constructing typical task, a minimum variance portfolio. So MVP might mean mean variance portfolio theory, but here it's the minimum variance portfolio theory, right? So we want to combine now Apple, Microsoft, and Google in a way that the variance of the portfolio is minimized. Very typical thing. You will see this also a number of times implemented used, leveraged in the asset management class, but also in other contexts as well. But in particular, in the asset management class, might make sense, right, that we go pretty deep there. We use minimize from optimize. We scale the average returns as well as the covariance metrics here to yearly, right? When we have a look at this, this now has much larger values than the daily ones. But again, keep in mind, please, that yeah, we are dealing with random values here, right? And yeah, when we define the portfolio variance, you see this is a double dot product. And I must say the syntax here with the add operator for matrix multiplication leads indeed to a more natural yeah, syntax, because with the dot product, I would need here a nested NP dot. I would need to apply it twice, first to the first result, then to the second result. So that's yeah, that's for sure here a little bit nicer. But you see Python, vectorized operations, NumPy, pretty straightforward, simple affair. And here the start for the optimization is the equally weighted portfolio, right? And we set here the bounds for the optimization, where we say that it's just 0 or 100. It's the lowest value or the highest value, and everything in between, but nothing above 1 or below 0. Here we do the optimization, so portfolio variance, initial weights, etc. pp. Yeah, we are finished with the optimization. If it was a success or not is checked here based on the control flow if else. If the result success is true, so if this defaults or if this is true, then we take out the weights here, the function value, then the standard deviation is calculated, and we calculate the expected return. Otherwise, we say, yeah, I'm sorry, the optimization failed. But this doesn't seem to be the case. Therefore, here in our simple case study, the weights with the random values, the random price series, and the derived returns here is 20%, 74%, and just 7%, right? Expected annual return and expected volatility, both of them, the one exactly 5%, the other one close to 5%, right? As simple and as straightforward as that. So one of the major theories, I would say the starting point of quantitative finance, with the publication of the paper Portfolio Selection by Harry Markowitz in 1952. Right here you see the starting point of the quant finance world implemented in Python with a few lines of code. So computational finance, yeah, option pricing is a typical task there, here implemented on the basis of Monte Carlo simulation. One shot or static Monte Carlo simulation to a future horizon, capital T. This can be 1 year, right? You see it here, 1 year. We have a certain risk-free rate that we need to define, right? From the beginning, like 4%, this was defined above. Then we need a volatility, which we calculate here from the Apple returns volatility, right? And do a certain number of simulations. And then we can here calculate under certain conditions the expected value of the simulated ones, right? So here the expected value is roughly here given the payoff that we need to calculate at the end, right? In computational finance, and also in a more introductory way in other parts, this is something discussed at length, right? And for me, this is always a little bit nostalgia because this is how I got started using Python well before NumPy was around, using it for Monte Carlo simulation and option pricing that way. So printing here the parameters, right? which are all based on the simulated values of Apple. Doing here the Monte Carlo simulation once again with a random seed, 42, you know, in the IT world, 42 being the answer to anything. Before it was 0. We calculate here the payoffs in a vectorized fashion. So when we speak here of 100,000 simulations, we just need this single line to calculate the 100,000 payoffs. The same holds true for the averaging over the payoffs and the discounting, just a single line. And in that case, the option price, the call option price, based on the Monte Carlo simulation is 5.7. Right? So last but not least, the third core topic in the CPF program, right? Is here algorithmic trading. And just looking for questions, I will answer the question after this final case study here, algo trading. So this is here something, again, you will see in similar form in the program. The case study is about backtesting a simple moving average crossover strategy on Apple. Once again, it is Apple, and it is my go-to example when I do something with equity prices and or returns. My second go-to example usually is the Euro-US dollar exchange rate, which you will notice rather quickly when you go through the program resources, right? So here the strategy is as usual. So we go long when the shorter simple moving average is above the longer one, and else staying flat. We could also go else being short. Here it's just flat, meaning nothing. So we just want to go long. So for many investors, this is a let's say a realistic assumption that they don't want to short stocks, right? They might want to buy put options, but this is more involved, right? But here we just say long when the average is above, the shorter one is above the longer one, or the faster one is above the slower one, else being flat, right? So mathematical background here is explained, and we again copy the prices now from Apple, calculate here rolling means for Apple, 10 days, 30 days, as in the description. Then we set here the position to 1 when the condition is satisfied and to 0 if not. So this is the mathematical and programmatic implementation of the description here, right? The description here, and yeah, accordingly set the position but shifted by 1 day. This is in order to avoid a look ahead or foresight bias, as it's called in the literature, right? So we cannot use data from that day in order to set up a position on that day, right? This would imply foresight. I can only work with data that is from, simply speaking, from yesterday or from a minute before, but not a minute in the future, right? Or even 5 seconds in the future. This does not work. Maybe you have a crystal ball, I don't know, but I don't have any, and many others obviously don't have any either. So the returns are now calculated based on the percentage change. So the backtest data, the asset return is here backtest data Apple percentage change. That's the asset return. And the asset return plus the position gives the strategy return. So we have the position, we calculate the asset return, the underlying asset, and by combining position with the asset return, we get the strategy return. Also something you will see so many times in a program in different contexts, but in particular this time around, obviously in the algorithmic trading class or classes, I can say. Here we calculate now the cumulative returns for the buy and hold, for the benchmark strategy, and the trading strategy. And last but not least, we show here a number of results numerically. And now, last but not least, I was a little bit too fast. We see here the visualization, which shows, particularly here, we are long in the beginning, right? And then we have the second condition that the faster moving average is below the slower one, and this is where it is for pretty long. It is here flat, so it doesn't invest, and here it goes upwards, right? So let me change on the fly here my condition to -1. Let's say we would go short here instead of keeping everything neutral, right? So let me change, or let me start up there. This is always better. So when I do now include short positions, you see that this indeed has quite a positive evolution over time, because when the market goes down, so here we benefit from the downwards movement by going short. Maybe I simply leave it here because this is a little bit nicer. Again, this is like, I know this is random data. Where are we? Where are we? I'm looking for the proper positions here, right? Else flat. So long when, else short. -1 or flat would be 0. So now we have the two options. So I have implemented here, right? Short. So long, short. I can also do this here as -1. Backtest NP where, or here long, I call it usually neutral, right? But I stick now because it simply looks better to the long short one, right? But this requires the ability to go short and margin, etc. pp, right? But just that we have here now the two options for us available. Yeah, this is more or less the end, right? So here in conclusion of our little safari and the beginning of your quant journey, on the way to become a super quant, right? So we have gone through all these different elements, and I think it's really kind of a good, yeah, abstract, if you like, of what is coming in the rest of this pretty long and detailed paper. We have covered NumPy, Pandas, right? SQLite as one of the major database technologies still around. So I just recently read a statistic that SQLite is used alone on more than 1 billion devices, like your phone, for example, right? So this is really something that is omnipresent, we can say. Scikit-learn for machine learning, transformers here in combination with PyTorch, and pre-trained models, in our case, pretty simple, straightforward sentiment analysis, a financial theory like in asset management, minimum variance, where we use SciPy, Monte Carlo methods. NumPy is our friend in combination with Pandas, and vectorized backtesting, also based on Pandas. It's absolutely, it's a bedrock. So if I would have if I would be able to do a time travel, let's say just 10 years back, and I would present a talk with the stuff that is in here, people would say, no, this can't be the case, that everything is as simple as that and as efficient if we would do some timing exercises as well, right? So that's indeed a long way that we have come, and I hope that you will be able, over the course of the program, to leverage all these tools, to make it your own, to put it in your own toolbox, and then add the AI elements to it that we have discussed in the first session so intensively, yeah, in order to become finally a super quant. And to the question whether it is recommended that we should run all Jupyter notebooks via Docker container with Ubuntu Linux rather than on the native operating system for reproducible output, I would say this is a good way to do it, right? But it's not necessarily required. there are certain topics where I would say, yeah, you should train and exercise in the Linux Ubuntu environment, because when you then want to move your code, let's say in algo trading, to the cloud, you will use the same environment, right? You will feel like back home if you work all day on Windows with PowerShell and here and there, and then suddenly you should change to a cloud-based environment with Ubuntu and Linux. This is, I would say, a big leap, right? And there is, I would say, another major reason that you, with the Docker containers, you can exercise that stuff over and over again, setting up the environment, checking whether everything is in order, working with the different tools on the Linux shell as well as on the Python side. And you probably don't want to have on your local machine forever and ever all the Python environments that you are going to create, right? So there are a number of reasons. There's no requirement in particular in the beginning for the standard classes. In tools and skills, you are expected to do it, but you could also in the beginning even skip that part. I don't recommend it, but you could. So there are a number of reasons to do so, but there is no hard requirement. I would say it is a good thing if you follow that route, but if you say, no, I want to focus more on the Python basics, on the financial elements, that's also fine. And this is something that you can do as well. Yeah, in that sense, here, this is what lies ahead of us. We have, when we have a look at the study plans, of course, I hope this is now ingrained in your mind and part of your motivational mapping there, right? The super quant vision. I want to go to the study plans, right? And week number 1, finance with Python, you should focus on, you should get started with the key skills. Here, tools and skills, which I mentioned a bunch of times, AI and finance. If you say, well, time is limited, I cannot do everything, I would, for example, skip the AI and finance part, right? The further to the right, yeah, the less harmful it is if you skip these parts, right? You should go from left to right, but you shouldn't skip the key skills Linux basics part. So this is really something that you should focus on, right? And in the beginning, you should in any case go through finance with Python. This is really fundamental. All the other classes expect that you have covered this in detail. Similar here for the TAQ program, finance with Python, I would say it's a must. Here you should, of course, go with AI and finance, book-based. If you say, well, time is limited, reinforcement learning for finance might be too much on the first go, that's fine, save it up for later. Same holds true for NLP basics, but here, the finance with Python, here, these key skills are in the first column. This is what you should focus on, and the further to the right, yeah, you might say, well, not this week, next week, or maybe on the second go. You know, you have all the flexibility, you have indefinite access, and yeah, you can study as your schedule, as your energy and motivation allows. I hope it is high, both availability of time, motivation, and your energy to go through the plentiful resources, right? Yeah, in that sense, let's wrap up today's session, our second kickoff session for the May cohort of the CPF and the TAQ. Exciting times ahead. I wish you all the best. I wish you the steepest learning curve, and that you have fun, in particular, acquiring all the skills and ingesting everything that you will present it with. Let me know, keep me posted, and yeah, as usual, take care. See you in the next session. Bye-bye.